Welcome once again to my YouTube channel on data analysis and research. Today we want to compare three groups of non-parametric data which are summarized as median, interquartile range. So when you have non-parametric data more than two groups and you want to compare to find out whether there's differences between the data distribution, it is recommended to use a non-parametric test. So in this instance, since there are more than two groups, we normally use it's recommended to use the Kruskal-Wallis one-way ANOVA or the non-parametric one-way ANOVA. So from this, we have already summarized our data as median interquartile range. So we want to find out the test statistics and then the p-value. So we'll go to our data. So this is our data here in SPSS. Go to analyze. So we moved down to non-parametric test. You choose, these are independent samples. So we have related samples or paired samples. You have the independent. So you select the independent samples here. So let's reset. So go to objective. So objective, we will leave the default. We go to field. So field, you move your variables to their respective places. So we have our categorical variable. That's the duration of the treatment. So we put it to groups. Then these are our variables of interest we want to compare, from creatinine to the estimated glomerular filtration rate. So we put it here. So go to the next field. So we want to customize and select the test of our choice. So we are interested in the Kruskal-Wallis one-way ANOVA. So we compare. So we will select all pairwise. You should compare all groups to each other to find out where the difference, if there's a significant difference, where the difference is coming from. So we select all pairwise. So that should be enough. So we go to run, and then our results will be displayed here. So you can see this is the comparison done. So this test here, the results here is telling you that when the three groups are compared, what is the difference between the groups. So these are all the three groups compared at once. So you can see that aside urea, the rest were not significant. So let's go to the multiple comparison, the pairwise, see what urea, where the difference is coming from. So if you come to urea, so you can see that the three groups are compared to each other. So the group that had duration from 1 to 3 is compared to those above 3. So 1 to 3 compared to less than 3 and all that. So if you come here, you can see the significance value here. So we have both adjusted or unadjusted. So when you do a post hoc test, the pairwise comparison is also a post hoc test. So we have the unadjusted. So you can see that there are two significant values here, but when they are adjusted, the significance is lost. So you can report as such. So that is how you come about. You get the p-values for Kruskal-Wallis test. So regarding the test statistics, you can see that this is the test statistics. So for each test, you find the test statistics value here, which I put over there. So that's the TS test statistics here. So I put the unadjusted p-values. So when you compare the column, second column to the first, is significant. So that means those less than 1 year on heart have higher urea than those on heart between 1 to 3 years. So similarly, those on heart more than 3 years also have higher urea levels than those in the 1 to 3 year category. But these are unadjusted. So you have to report that these are unadjusted p-values, so that when you are discussing the results, you will discuss as such. So thank you very much for watching. Please subscribe, like my channel, and also share with your colleagues who are interested in research and data analysis. Thank you, and see you next time.